Another supervised ML algorithm is the k-nearest neighbor, abbreviated as KNN, which can be used for both classification and regression. Now, in our example here, where we're using the housing dataset, where our goal is to predict the price of a house, you're going to use the class k-neighbors regressor, which is just an implementation of the k-nearest neighbor, but for regression problems. So if you go to the API reference here, we can see here we have two k-neighbors, one for classification and one for regression. We click on this one. We can see that these are the parameters, right? This is our k here. By default is 5. These are some of the attributes. So in our case here, we're just going to use the parameter k here. Okay. Now, the key idea with KNN for regression, in our case here, we want to use the average of the outcomes values for the k nearest neighbor, all right, of a new data point as its prediction. So in our case here, 5. Okay. So using this k-neighbors regressors class, we provide an implementation of this algorithm of KNN, which allows us to specify this value k, right? And the distance metrics we use here will determine the nearest neighbor. That's the key idea. Next, we're going to create an instance of the neighbors regressor class by this line, and then we call it KNN underscore model, right? We've already created that, and then we fit on this line. We just fit the model, right, using the model to fit. And then again here we also use the model to predict. In our case here, we're going to store this into this variable y underscore pred underscore KNN. Then we evaluate that based on r squared. So we just get that from the metrics and also mean squared error, right? We use NumPy here to get a square root for that to get RMSE. So we can see our KNN doesn't do very well, but we can also visualize this just to see, and you can see there is a big gap. The objective function here is to minimize this distance here between predicted and the actual value. So compared with our ridge regression and linear regression, the R squared was almost 91 and above. The goal here is to have closer to 1, right? So this is not doing very well. But let's look at other, different algorithms as well and see how they compare to KNN.